Hello everyone, in this module we are going to understand how to use the arithmetic operations on NumPy array. Next we are going to discuss about how to perform calculations using arithmetic operations, and we will discuss the different types of arithmetic functions. First we will discuss what is arithmetic operations in NumPy. So basically Python NumPy provides different arithmetic methods such as subtract, add, divide and multiply, which performs on a NumPy array. So here we will understand the different types of arithmetic functions which we are going to apply on arrays. So these are the most important use arithmetic functions. Now let us briefly understand the concept of these functions. First we will discuss the np.add function. Basically this function is used to add values of two NumPy arrays element wise. To use this function you have to check the shape of a given input array and also check whether the length is the same or not. For example, suppose you have taken two arrays of same size with same number. If you use the numpy.add function, then it will easily add the elements. So basically this is a universal function and it accepts several arguments. Now let us look at the syntax for this function. So numpy.add is a function name, and within this function there are mainly three parameters which we are going to use in examples. The first one parameter is x1. This parameter indicates the first input array for calculating the addition. The next one parameter is x2. It specifies the second input array for calculating the addition. The third one parameter is out. This parameter indicates the location where the result is to be stored. The next one parameter is where. This is an optional parameter and it will check the condition. If the value of where is true, then it will measure the universal function at that position, and if the value is false, then it specifies to leave the value, and it will always return a new NumPy array that stores the element wise addition of the values of a given array. So guys, remember one thing: if the input array is scalar, then the output will also come in a scalar order. Now let us see an example of how to use the numpy.add function with an integer value as an argument. Here I have taken an example, and in this example we have created two input arrays. The name as number of pens and the second one is number of pencil, and within this function we have assigned a numerical integer values. Then we have used the np.add function and it will find the addition between input arrays. After executing this code, the output comes the addition of two input arrays. So after understanding the concept of numpy.addition function, now we will discuss the np.subtract function. So basically this is a part of a NumPy arithmetic function and it is a universal function that is available in the NumPy package. So suppose if you want to calculate the difference between two NumPy arrays element wise, then this function will easily get the subtracted array. When you use this function on the same size of input arrays, then the function will subtract the values of the second input array. So here is the syntax of np.subtract function. Numpy.subtract function is a function name, and within this function there are three main parameters. The first one parameter is x1. This parameter specifies the first input array for calculating the difference. The next one parameter is x2. This parameter indicates the second array for calculating the difference, and the third parameter is out, that specifies the location where the result is to be stored. Now let us discuss about this function with the help of an example. In this example we have created a two-dimensional array. In both of our input values, the first one is integer values by using np.array function, and within this function we have assigned a numerical integer values. So after creating an array, we have used the np.subtract function, and also before using this function you must have to check whether the array has the same size or not. Now we have used the np.subtract function, and within this function we have assigned two input values. The first one is integer values and the second one is numeric values. So after executing this code, the output comes the difference of two NumPy arrays. The next arithmetic function is np.multiply. So this function is used to calculate the product between two NumPy arrays element wise, and this function will help the user to multiply every element of the first array with the relevant part of the second input array. Both the input arrays have the same dimension and shape while doing the element wise multiplication. Now let us create a two-dimensional array and multiply these elements by using the np.multiply function. So In this example, we have created a two-dimensional array in both our input values, that is product ID and the user ID. In the next, we have used the np.multiply function for multiplication of arrays element wise. So after executing this code, the output comes multiplication of two numpy arrays, and that is two-dimensional array. Now we will understand our next function, that is np.divide function. So basically this function is used to calculate the division between two numpy arrays. The values in the first input array are divided by the elements in the second input array. So here is the syntax of numpy.divide function, and within this function the first one parameter is x1. It specifies the input array elements and it also acts as a dividend. The next one parameter is x2. This parameter acts as a divisor and it will check the condition. If the shape of an array x1 and x2 are different, then it must be a broadcastable. The next one parameter is out. This parameter indicates the location where the result is to be stored. Now let us take an example and check how to use the np-divide function in Python. In this example, we have taken two arrays named as list of numbers and the second one is divisor number. It consisting of integer values. So we have assigned these two arrays as argument inside the np.divide function. The first parameter acts as a dividend whose values need to be a dividend, and the second one is divisor numbers, act as a divisor. The output of a division is stored in a variable named div. So after executing this code, the output comes division of two input arrays. So after understanding the numpy.divide function, now we will discuss about np.mod function. So basically this function is used to return the division of two input arrays element wise. In this function, the first parameter specifies the dividend array and the second parameter specifies the divisor array. So here is the syntax of np.mod function. This is the function name, that is numpy.mod, and within this function the first parameter is x1 and it specifies the input array of values that are the dividends. The next one parameter is x2. It specifies the second input array of elements that are the divisors. The next and last parameter is out. This parameter indicates the location where the result is to be stored, and rest all the parameters are the optional parameters. These are not mandatory to use in our example, so we have used only three parameters. Now we will see an example of a numpy.mod function. So in this example, we have created two input arrays. The name is number of cars sold and the second one is number of bikes sold by using the np.array function. Next, we execute the numpy.mod function and assign function on the given arrays and assign the result to a variable result. So after executing this code, the output comes the remainder array, that is 0, 0, 0. The next one function is numpy.reciprocal function. Suppose if you want to get the reciprocal of array values element wise, then this function will help you to get the result. Now let us discuss the numpy.reciprocal function with the help of an example. In this example, first we have imported the numpy library. After that, we have created an input array by using np.array function, and within this function we have assigned the integer and the floating value in it. After that, we have used the np.reciprocal function and assigned the array as a name sample number to it. So after executing this code, it displays the value in the order of one dimensional. Now we will understand our next function, that is numpy.power. So numpy power function is a part of arithmetic function in numpy, and this function is available in numpy, in which the first element of the array is the base, which is raised to power element of second array, and finally it will returns the value. Now we will see an example of a numpy.power function. So in this example, we have declared two input arrays named as base num and the exp num. The array base num contains 5 elements and the array exp num also contains 5 elements. Here the first input array base num is going to be the array of bases, and the second input array specifies the array of exponent. After that, we have used the np.power function and passed both input arrays to it. So after executing this code, the output comes a new array. Now we will understand our next method, that is np.real. So basically in a complex number, there are two parts. One is a real number and another one is an imaginary part. So this function is used to get the real part from the complex number. So here is the syntax of numpy.real, and within this function there is only one parameter, that is val, and it specifies the input array which is in the form of complex number. Now let us discuss the numpy.real function with the help of an example. In this example we have created an array in the form of complex values. After that we have used the np.real function, and within this function we have assigned the array that is complex num. After executing this code, it will extract only real numbers from a complex values. So after executing this code, the output comes in a real part from array. And suppose if you want to get the only the imaginary part from complex values, then you can easily use the np.imag function, and within this function you have to pass the array that is sample numbers. So after executing this code, only the imaginary part from array. So with this we have completed the numpy arithmetic functions.